Hello everyone, I'm Paul and today we're solving problem 3362, Zero Array Transformation 3. This is a medium problem and this is the third part of a series of 4, I think. This is a tricky one and I think it's very interesting, so here we'll go over the intuition, approach and efficient solution. We're given an integer array nums and a 2D array queries where each query has two values, left and right. And for each query we can decrement the value at each index in the range from left to right in nums by at most 1. Our job here is to return the maximum number of elements that we can remove from queries such that nums can be converted into a zero array using remaining queries. And if this is not possible, we return -1. Let's see an example. Let's say this is num and this is queries. So first we take the first query, which has this range, and we are subtracting 1 from every element that's not 0. So this is now a 1 and this is now a 1 because this goes from index 0 up to index 2. Next we take the second query and we do the same. We subtract 1 from here, so this is now 0. We subtract 1 from here, so this is now 0. Now we have an array with all zeros. We have used these two queries, so this query is not used, so the result for this is 1. Now the question is, how can we know that we won't use this query in a reasonable time complexity? Let's go with another example and how to solve this. Let's say we have these nums and these queries. Our first step will be to sort these queries by the first value in each array. So we'll have this. And now let's say we have two bags or containers or things to store other things, and we have two of them. One will be the one we'll use to store queries that we are not using but that we can use. We'll call this available. And the other bag is to store queries that we are already using. We'll call this current. And we are iterating nums from left to right, and at each point we are adding and subtracting items from these bags. So here we have the bags, and first the I pointer is at index 0. Now I is here, and we need to check which queries can we add to our bag of available queries. And the answer is those queries for which the current index is inbound. So for example, if we take this query, this goes from 0 up to 2, and 0 is inbounds here, so we can add this query. But if we take this one, for example, 0 is out of bounds here because this goes from 1 to 1. So the only query we can add to available is this one. But we don't need to add the entire array. We can only add the second value. So we add a 2 here. You will see why in a few minutes. And every time we add a query to available, we can remove the query from queries. And now nums at I is 1. This means we need to fill 1. The requirement is 1. And this means we need at least one element in our bag of current queries. So first we are checking if we have available queries. We have one available query. And then we are checking if the biggest available query, in this case 2, is bigger or equal to the current index, which is 0. In this case it is. So we can move this query from available to current. Now we have one element here. We need to fill one element, so we are good to go and we update I. If we didn't have enough elements here in current, we would return -1 because we could not build any zero arrays. So next we update I. Now I is here and we are checking which queries are available. And the queries for which index 1 is in bounds is this one, because 1 is in between 1 and 1, this one is in between 1 and 2, and this one because 1 is in between 1 and 3. So we add the right value for each of these. So this is now 1, 2, 3. And we remove the queries from the array. Now the requirement is 2, num_i is 2. This means we need 2 elements in current, but we have 1. We need to move at least 1 element from here. The question is which element should we move? And we are moving always the biggest element. Why? Well, because remember, we are trying to use the smaller amount of queries because we need to return the maximum amount of available queries. So in this case, we are moving 3. Now we have 1 and 2 in available and 2 and 3 in current. And we have 2 elements here. Our requirement was 2, so we are good to go. And we update I. Now I is here. We don't have any more queries. And we have 2 queries that we are using currently. And the requirement is 1. So we are also good to go. And we update I again. Now I is here at index 3, but let's see our bag of current elements. We have a 2 here, but this 2 is now out of bounds because we are at index 3. So we remove this from current. Now we only have a 3 here, we only have 1 element, and luckily for us the requirement is only 1. So here we are also good to go. So we update I, we reach the end, and this is our final state. We have 2 available elements. This means we could have removed this query and this query from the original array, and only with this and this we would have gotten an array with all zeros. So the result is 2. This is it for the approach, and now let's go with the code and hopefully you will get the idea. First we'll say n equals length of nums, and then we need to sort queries, but we are doing this in reverse order, so the left smallest value is to the right, so we can pop queries efficiently. So queries.sort, and this is reverse equals true. Next, we can do this with sorted lists or with max and min heaps. So in this case, we are using sorted lists. We'll say available equals sort lists and current equals sort list. And now for I in range n, while we have something in queries and the last query, specifically the left value of the last query, meaning index 0, equals I, we want to add to available that last query. So queries.pop at index 1. Next, while the length of the current bag is smaller than the requirement nums_i, if we don't have any element in available, so if not available or available at -1, meaning the greatest available element is more than I, we return -1 right away. Else current dot add the last available element, available dot pop. Here in between, before this, we'll say while current and current at 0, meaning the lowest current element is more than I, we want to pop that element, so current dot pop at 0. Okay, you can do that like this. And next, if the length of current is smaller than nums at I, we return -1. Okay, because we didn't fill the requirement. And finally, we return the length of available. Now about complexity, this runs in q log q, and this runs in roughly n log n, because we are iterating every index in n, and the operations for the sort lists run in log n. So this is overall n log n, and overall time complexity is n log n plus q log q, and space complexity will be roughly n plus q. So this is it for the code, and now we'll submit this and see if it works. And as you can see, this works. Remember, you can solve this with min and max heaps also. And if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.